Hi guys, Buildzoid here, and today we're going to be taking a look at the first ASUS X570 motherboard PCB, the Crosshair VIII Hero. I've done way too many takes of this video, because unfortunately every time I get a good, interesting motherboard, there's just so much to talk about that basically the video ends up an hour long, and I'm like, okay, you know what, we need to do this from the start. And then I reshoot it, and it's still an hour long, and I'm like, I don't know why, I didn't talk about some, I removed some random detail, and then it's like I add something else, and it's a stupid long. So whatever happens from now on until the end, it's going up. Like, I give up, because I've tried to shoot this video too damn often, and anyway, fun fact about this board, I'm not supposed to have pictures of it. So, yeah, if you've been wondering, like, Buildzoid, why haven't you been doing any ASUS motherboard videos, it's because I literally can't get pictures of them. So, yeah, I'll not go into too many details about it because it's not really worth it, but thanks to a fan of the channel who does have access to these boards, we now have pictures to look at, so... yeah, that's great. And the thing is like, I think the reason why I'm not supposed to have pictures is because apparently, like, I'd probably, like, rip on the motherboards or something, because, let's be honest, I think I've been giving ASUS kind of a hard time for a while now. But this is a board I really, really like, at least on paper. Like, assuming they didn't do something stupid with the Precision Boost Overdrive implementation like they did on, say, the Crosshair VII Hero or something like that, this could be easily, like... and this is actually, like, I wouldn't say the go-to board for X570, because on X570, at the price range where this board is located, it's going up against the Master from Gigabyte, and it's also going up against the Ace from MSI. And all three of these boards are, in my opinion, very good. Like, any one of those, like, you could take a six-sided die and label, you know, 1/3 of the values on an Asus MSI Gigabyte, roll it, and whatever it lands on is a good choice. So, yeah, that's kind of the situation with these motherboards. For me especially, because, like, I don't even care which BIOS I'm dealing with, because I can tolerate even Gigabyte's mess. And then Asus BIOS, well, actually, there's some things about Asus BIOS that I really don't like, actually. And I think I'm alone in that, where it's just like the way XMP is enabled on Asus boards is silly, in my opinion. It should be complete, like, the way, well, whatever. Nobody cares. We're here to talk about the board, not about weird things you don't like about Asus BIOS, right? So let's get right into it. Starting off with the extra 4-pin power connector. So this is one of the boards where I'm like, oh, look, we have a board where this actually is legitimately a useful thing to have, because the Crosshair VIII Hero, following up from what the Crosshair VII Hero did, is fully equipped for LN2 overclocking. So this is actually really useful because, yeah, this is an LN2 overclocking board. It's got all the LN2 overclocking features. And so, you know, you do need the extra 4-pin because on liquid nitrogen, you can get, even a 2700X can pull 400 plus watts if you're on liquid nitrogen. So... yeah, with the 3950X coming out on liquid nitrogen, that is going to overwhelm a single 8-pin. So the 4-pin actually becomes useful. Now, if you're at ambient, you can just stick to the single 8-pin because the minimum amount of power that this connector can handle is like 384 watts, which on water cooling, you know, even if you totally max out a 3950X, it is not going to exceed that 384 watt CPU power consumption. So you're going to be golden with the 3950X with just the 8-pin. And yes, the board will work if you don't plug in the extra 4-pin. I hate how many times I get that as a question. Like, seriously, it's just like... also, the worst part is like, can't you just go look it up? Right? I swear Google is a thing. You can just Google this kind of stuff a lot of the time. But anyway, so yeah, since I've already talked about it, if you're on ambient, you just plug in the 8-pin and you ignore that the 4-pin exists. If you're on liquid nitrogen, you plug in both of them. Nice and simple. Next, we have the postcode, and I am actually going to be leaving labels everywhere because there's so many damn features on this board that I've actually, like, on past takes, I swear I've... ambulance. I swear I've, like, repeated certain, like, gone over certain features twice because it's just, like, there's so many of them and I lose track. So Next, we have the postcode, obviously super handy for troubleshooting any kind of boot up issues. Then we also have color-coded troubleshooting LEDs under that. So those are good for getting a like rough idea of what's probably wrong, because they'll tell you like if you have a boot media issue, GPU issue, CPU issue, memory issue. And then when you want more details, you can just look at the postcode. Like I actually like this. I really do appreciate this when you're doing memory overclocking. You know, just the color of the LEDs can often tell you like, hey, this. Like if the color order of the LEDs is correct, you can already tell, and the timing is correct, and eventually you can just kind of tell, okay, I did my settings correctly long before the postcodes stop rolling. So, that's one thing where it's just like this is super handy. Of course, you could also just memorize which postcode is like memory training complete, but that takes longer to do than just memorizing which color means success, right? So, I do like that the ASUS has that implemented this way, because a lot of other board vendors, they'll just have the same color and they'll put the LEDs like right next to each other, and then it's like, well, the board is glowing from the same spot as always in the same color as always. It doesn't really mean anything, all right, until you try to look at it closely. And on some boards, it's actually really hard to tell which LED is lighting up, because you're looking directly at a light source, trying to tell like if the light source is 1 millimeter to the right or 1 millimeter to the left, and it's like, well, can't see anything. But anyway, so, big fan of that. Then we have the power, the reset, and I should keep those circled so I don't forget about them, which I probably won't do. Power, reset, and then we don't really have anything down here. I have notes. Covering all the features, but it's like they don't correlate with the image, if anybody's wondering. We have the CPU, we have the hole in the CPU socket for putting K-type thermocouples through. The idea behind this is that you can basically like stick a K-type thermocouple to the back of your CPU, and if you're on liquid nitrogen, you can monitor the condition of your thermal paste, even when you're, deep below zero. Because normally what happens is at around 0 degrees, a lot of temperature sensors just stop working, or more like the software refuses to give you a reading at below 0 degrees. So yeah, and also at some point the temperature sensors just get really inaccurate, and so this is what you would use to make sure that you actually know what temperature like the back of the CPU is at. It's not a die temperature, but it'll give you a much better idea than just looking at the temperature at the base of the LN2 pot. If the thermal paste fails, because you basically won't see much of a difference on the LN2 pot. But you will see a difference if you have a K-type, glued to the back of the CPU to check the CPU temperature. So it's nice to have that, which is a pretty heavy, like that's very much like an extreme overclocking feature, right? Like you don't need this on normal boards. Next, we have this here op amp, and the idea behind this is that basically, ASUS is using this to get more accurate voltage. Well, basically, there are some very high accuracy voltage measurement lines integrated into the CPU socket. So you have the on-die voltage sensing built into the CPU, which is meant for use by the voltage controller, which is on the back of the board in this area. And the thing is, you can't really, because that's supposed to be a really high accuracy voltage measurement, you don't want to be getting random noise, switching noise getting onto that line and that kind of thing, so that the voltage controller can actually do its job properly. So what ASUS is doing is they have this op amp to basically mirror that voltage onto the voltage read points, and also to mirror it for the Super I/O chip, because otherwise the Super I/O chip on most motherboards just measures the voltage across, say, a capacitor, like this capacitor right here, or this one. Well, actually, this one's probably memory controller, so I don't know. It'll measure the voltage before the CPU socket, and it'll actually measure high rather than the silicon level voltage. So yeah, this basically gives you more accurate voltage measurements than what you get from the Super I/O. Now, to be fair, on a lot of other motherboards, you can just check the voltage reading directly from the voltage controller, right? If you're, especially on Gigabyte boards, this seems to work really well with hardware info. You can just look at the voltage reading from the IR35201, and it'll give you the exact same reading as what ASUS is using this op amp to achieve. But still, this is definitely a nice feature, and it does mean that your voltage read points and your Super I/O and your voltage control, all of those measurements are going to be from the actual die of the CPU rather than somewhere before the CPU socket, right? Because the CPU socket has a bunch of resistance, so you're not going to see the actual true core voltage if you measure it off the back of the CPU socket. So, and this is a standard feature for a lot of high-end ASUS motherboards for a very long time now. So, yeah, that is Like that's a really, really cool feature, though. Personally, I think for a lot of other board vendors, if they just made it so that software always hooked up to the voltage reading from the voltage controller, especially if they're using like an intercell, like a high-end digital controller like an ISL 69138 or the 35201 from International Rectifier, like it gives you the same voltage reading. It's the same thing, right? So, yeah, to some extent this is unnecessary, but it does mean that, you know, if you're a beginner and you just check the first piece of software, which most software just picks up the Super IO, you'll get a voltage reading that's actually correct instead of before the CPU socket. So that's what's going on with that, and I think that covers everything. Oh no, well, there's also 2.5 gig Realtek LAN on this board, so that's this chip right here, and that's this port over here, so that's 2.5G Realtek. There's also 1 gig Intel. So that's a nice combination of networking, because personally I'm a sucker for Intel LAN, and then the 2.5 gig Realtek, well, if it doesn't work well, you don't have to use it, right? You still have your 1 gig Intel, which in my opinion, like 1 gig Intel should be a requirement for high-end boards, because it's just like that's the only LAN I've never had like issues with. And as far as I can tell, most people agree that like it's really reliable, though I don't test networking equipment. Okay, it's just like my very unqualified opinion on networking. 1 gig Intel LAN works. So yeah, unlike some of the other stuff I've used. So that's what's going on with this side of the board, and then we actually we have even more features on this board. Yes, it just doesn't end. So then we have clear CMOS on the rear I/O and BIOS flashback. So, you know, clear CMOS on the rear I/O, best location for it in my opinion, because it means you can clear the BIOS even if your motherboard is inside a case, which is a thing that people apparently do. But you know, I run test benches, so I wouldn't know about motherboards in cases. But yeah, so you do have that on the rear I/O, which does mean, you know, you don't have to take the whole system apart to clear the BIOS if you're having boot up issues. And then you also have BIOS flashback, which allows you to update the BIOS of the motherboard without even having a CPU installed, which does mean that if you want to, you know, install a CPU that's not yet supported on the board, you can update the BIOS just fine. You don't need to get like a previous gen supported CPU. Then this USB port is like the specific one for the BIOS flashback functionality, and there's a whole bunch of other requirements for making that work. You can look them up in like the ASUS motherboard manual whenever that gets published for this board. So that covers all the parts of the rear I/O I care about. And then on the bottom edge of the board, we get LN2 mode. LN2 mode on ASUS motherboards basically, like, it kind of varies board to board what it does. So on some boards, it'll actually preload like a whole bunch of LN2 settings so that you don't have a cold bug and a cold boot bug. On some boards, it literally just raises your maximum voltage limits. So normally ASUS will have, say, 1.5, 1.6 volts as your maximum core voltage limit, which is already too high for most daily usage. And you know, for daily usage, that's already way too much voltage. But if you switch the LN2 mode on, then the voltage limit goes up to like over 2 volts, and that's enough voltage to kill the CPU instantly if it's not very, very cold. And even if it's very, very cold, with enough voltage, you can kill anything instantly. Like, though it might not yet be high enough. So yeah, it also depends on the CPU architecture. So LN2 mode, very much just for extreme overclockers. Then we have Safe Boot, which is my favorite button of all time. Literally the best thing ever. Best button ever to be put on a board. The whole point of Safe Boot is that basically you can get into the, like, let's say you're overclocking for an hour your memory and you haven't saved any profiles and the system stops posting and you can't get it to post. Well, you can just hit Safe Boot and you won't lose all of your BIOS settings. That's the best thing about the Safe Boot button, is that you can get back into the BIOS at safe settings. But it won't wipe it, right? Because the other option is that you'd have to clear the BIOS, and then it's just like, well, now you have to redo all of your settings, right? And if you haven't been saving profiles, well, you've pretty much just lost like an hour worth of settings, and you better hope that you still remember all of them, because you know you just wiped them. So that's kind of that. Next to that, we have the retry button. This is basically a brute force for memory training. So when pushing very hard memory settings, like say 3733 CL11 or 4200 CL12 or 4800 CL14, and I'm just listing off settings that are standard for benchmarking on like Intel systems, not necessarily Ryzen. I don't know if the 3rd gen memory controllers are going to be able to do 4800 CL14. I don't even know if 4800 CL14 will be the best settings to run. It might turn out that it's actually not higher performance than, I don't know, 4200 CL12. I don't know how it scales with liquid nitrogen. Maybe at ambient it'll be best to run like 3311, that kind of thing. But a lot of these very high performance memory settings run into the issue of that they don't train instantly. So basically you'll get stuck on a couple different random post codes. And if you're getting stuck on those post codes, it doesn't mean that your memory settings are wrong. It just means that you need to mash this button a bunch. And sometimes, some other post codes would basically mean that the retry button isn't actually going to help you. It's just like your settings are wrong and the board can't do anything about that. So yeah, this is very useful for competitive overclocking. And then, because, even at ambient, you can use that. Like there's, especially with like Samsung VDI, you can do 4000 CL12 with a lot of the good sticks on it at like 2 volts. And actually you can even go all the way up to like 4266 on air cooling with Samsung's VDI at like over 2 volts. So, yeah, that's really, that's at least on Intel systems. AMD 4266 CL12 is not a thing, but not yet. Well, it hasn't been a thing. I don't know if it is now, but yeah. So for even for ambient, this can be very, very helpful. Over here we have the slow mode switch. This allows you to immediately just drop the CPU ratio down to the minimum CPU, well, down as low as it goes. And the idea behind this is that if you're on liquid nitrogen and you're like saving a screenshot or something, you don't want to be saving a screenshot at 5 gigahertz because that just increases your chance of crashing in the middle of saving a screenshot, which considering that you need to save a screenshot of your score so that you can share your score with people, that's kind of important that it doesn't crash when you're doing that. So that's one use for it. And sometimes it can also help with like booting into the operating system and that kind of thing as well. So we do have the slow mode switch for all of that. Also, this is very much an extreme overclocking feature. At ambient, you don't really need to use it at all. Actually, I can't think of a single reason to use it at ambient. So yeah, that's kind of that. Oh yeah, I forgot. Well, I guess I kind of mentioned the voltage read points in passing when I was talking about the op amp, but you do have voltage read points over here. Covered all of that. So safe boot, we've covered. Retry, probe hole, yes. LN2 jumper, yes. Slow mode, yes. Upgrade, yeah, that's the op amp. Clear CMOS, covered. BIOS flashback, yeah. LAN, we've covered. So that covers all of the sort of overclocking features on the board. Also, if you're wondering what's going on with like why the 24 pin doesn't have all the pins the same, so that's the high current version of the power connector, which you'll notice that that's the same type of pin as over there. And then this is the low current, like these pins over here are the low current variant of the power connector, well, of the pins. And on it, like I know this looks really cheap, but honestly, it doesn't make much of a difference to the cost of manufacturing the board, which is also why most board vendors don't bother with it. It's just like they'll just use the high current pins for everything in the 24 pin, but at the same time, this really doesn't make a difference to the quality of the board because all of the other pins in this are like, there's a bunch of grounds which are completely redundant because there's a ton of them. There's a bunch of signal pins in that don't really handle any current. So, they don't need high current don't need the high current version of the pins. Like that's there for the plus 12 volts line. So yeah, this is, like, it looks weird, but it's completely fine. It doesn't actually change the quality of the board. It's just like ASUS is saving money on things that don't matter, which is fine, because if it doesn't matter, then why would you spend more money on it, right? Like, that kind of thing. Anyway, so yeah, that covers all of the sort of overclocking features on this board. And yeah, it's really heavily loaded for extreme overclocking. So I'd be... like, honestly, currently with all of the boards that exist, this is probably going to be the go-to extreme overclocking board for the X570 platform, just because, like, Gigabyte technically is probably capable of doing extreme overclocking. I don't think they've released a board... well, no, they have... the thing is, they don't really care about supporting it properly anymore. MSI technically has a bunch of LN2 overclocking features, but they're all on the Godlike, and the Godlike is expensive to the extreme. Like, it's twice the price of this board. Then the And then ASRock doesn't really do extreme overclocking doesn't really support extreme overclocking on AMD that well either. They're kind of in a Gigabyte situation. Actually, they're in, I'd say, a worse than Gigabyte situation, because Gigabyte's they don't have an extreme overclocking division at Gigabyte, but their overclocking support is sometimes it's there, sometimes it's not for LN2. And then with ASRock, it's like their Intel boards can be really, really solid, but their AMD boards have so far had a terrible track record. So yeah, ASUS is this is probably going to be the go-to board for LN2. The other go-to board for LN2 could be the Crosshair VIII Impact, so the little mini DTX board, because well, that one has 2 DIMM slots instead of 4, and that makes memory overclocking better. So yeah, that's what's going on with the extreme overclocking support, and this board's probably just going to be the best for it, or at least the most cost-effective and easy to use for it. Depending on like if Gigabyte has all the necessary settings or not, and if ASRock has all the necessary settings or not. But Gigabyte and ASRock definitely don't have things like safe boot and retry. So, you know, that like those are in my eyes already pretty major losses for extreme overclocking support. So I think that covers all the features, right? Yeah, we went through all of the features. And so at this point, we got to talk about the VRM. And this may look like a 14 phase, or well, like a 16 phase, but this is an ASUS motherboard, so the question remains: did ASUS discover the magic of the Infineon XDP132G5C? And the answer to that question is no, they didn't. That blurry mess over there is an ASP1405. And that is the same, here's the thing, this is probably a rebranded IR35201. It's the standard high-end voltage controller for all ASUS motherboards, because as I just said, ASUS has not yet discovered the magic of the XDP132G5C. And the downside of this chip is basically it only goes up to 8 phases total. And ASUS here is running it as a 7+1. They're, of course, not using any doublers, because ASUS decided that with how their VRMs are built, they would like to prioritize transient response performance over, having like full current balancing or slightly more efficiency, because ultimately, once you get up into the really high phase counts, it's just like, well, yeah, the doublers kind of don't make a difference at that point. So, yeah, basically, ASUS decided that, we're not going to use doublers. I don't really see a problem with that for a VRM like this. It is still a 7-phase, and it's a 7-phase using some very, very high-end power stages. And also, for the actual phase assignment, so you have, actually, the only concern I have is the single-phase SoC VRM. Because, and that's probably here. So this right here is supposed to be the SoC. Why they put it there, I have no idea. I think it's mostly an aesthetic thing to get their capacitors all in this nice line instead of trying to squeeze them in somewhere around here, right? Because you do need some bulk capacitors for your SoC rail, which technically this SoC/IO rail, because now we have the IO die, which is no longer a system on a chip because Ryzen is now 3 chips instead of 1, but you get the idea. I'll just keep calling it the SoC rail. I could go full MSI and call it the Northbridge rail, because MSI calls it SoC/Northbridge. But yeah, no. So that's the SoC rail, and it is a single phase. And the thing is, most other boards are 2-phase SoC power without doublers, or you go full MSI where it's just 4-phase SoC with a quadrupler, and it's just and the thing is. I don't actually this board's not designed for damn it. Great. Well, whatever. We're going to keep rolling. I'm not reshooting this video again. So my voice is going to, it's not going to go away. It's just I'm going to sound different for the rest of the video. So anyway, yeah, this is a single-phase SoC VRM, but the thing is, it's not meant for powering APUs, so I assume they're just kind of we're just going to deal with the, since it only has to power the memory controller and the system-on-a-chip portion of Ryzen's, it's that really doesn't pull that much current, so the fact that this is a single-phase really doesn't probably matter much, if at all, and they could always compensate for it with just running that SoC, you could... Yeah, you should be able to just configure in the Digi Plus menu of the ASUS BIOS, you should be able to just set the switching frequency for that to like a megahertz, and there. If there was a ripple problem before, there isn't now. Because you can just compensate for that you can compensate for the low phase count with switching frequency. So you can also compensate for low switching frequency with phase count. That's kind of why doublers exist. But anyway, so that's our SoC phase over there, and I think they're putting it in the middle here for like reducing the thermal density of the VRM. Though at the same time, it feels like on this VRM, it probably doesn't make much of a difference because, well, that is all V-core, and this is also all V-core. So like the only this phase benefits from that, that phase benefits from that, this phase kind of benefits from that. All of these phases up here, they're still just one big blob of V-core. So, yeah, that they probably like. I'm not sure how much benefit it has. It might be to reduce the thermal density near the I/O section though. So, I don't know. Like, I think it's probably mostly just to get the capacitors in a nice line instead of actually like thermal. Because the thing is, this VRM doesn't even need a heatsink in the first place. So it's just like, why they're worrying about like, why get fancy with the location of that? I can't think of a good reason to bother. So anyway, for the power stages, ASUS is going with the IR3555, and yeah, that's a 55, not 50, which is actually a real part. That's the predecessor of the 3555. But the 3555 is a 60 amp POW IR stage. Also, the current rating for power stages, don't like consider it. Okay, just like the thing is that 60 amp current rating is at like 10 watts of heat dissipation. With 14 power stages in this VRM, that's 100. Like if you actually pushed 60 amps through each and every one of the power stages on this motherboard, it would be producing about 140 watts of heat. Not viable at all. Like it's not a relevant rating. This rating basically is more of a, it's kind of like how, well, like if you had one power stage and a big heatsink dedicated to it, yes, it can do 60 amps. But with 14 of them, no, you can't push 60 amps through each and every one of them. So anyway, that's kind of something I have to point out because I've seen a few people go like, oh my god, this VRM has like 1,000 amps current rating. No, it doesn't. If you pushed 1,000 amps through it, it would produce so much heat that you'd need like a custom water block to deal with it. And you don't have that. So it doesn't count, right? That kind of thing. But anyway, so 60 amp POW IR stages. And yeah, ASUS is just putting 2 of them in each phase. So like this is a phase, that's a phase, that's a phase, that's a phase. And this is a thing they've been doing for ages because, they get better transient response out of this. They also manage to reduce manufacturing cost because you don't have to pay for a bunch of doublers. Right, and the end result is that we do have this sort of monster 7-phase VRM configuration because each of these 7 phases is 60 amp, 2 60 amp power stages. So you basically have like 120 amps theoretical current throughput per phase. There's a couple downsides to this. Your phase shedding is really limited. Like you can't actually run just one power stage. Like at very low loads, you couldn't run a single power stage. You'd have to run 2 because you can't independently control them. So your very low load efficiency would be terrible, actually. So in like a laptop, this would be totally not usable because you'd be burning like 2-3 watts. Like actually, you'd be burning like a whole extra watt of power because you can't turn off the extra power stage. And the other downside to this is, well, that's actually like the main downside is your phase shedding is kind of awkward. You can't current balance them either, but they'll sort of self-current balance just based on whichever power stage is hottest will actually be handling the least amount of current because they're generally the RDS on of the MOSFETs will be higher in whichever power stage is hottest. So current goes through the path of, well, the bulk of your current will go, more current goes through the path of lower resistance. So, if this one is at like 105 degrees and this one was at 95 degrees, well, this one's going to be lower resistance. So the current's going to, more of the current's going to go through there than through there. So it'll sort of self-current balance just due to that. But it's not as well controlled as if you actually had doublers with current balancing functionality enabled somehow through the controller or through the doublers themselves. So yeah, and another thing worth noting about the 60 amp POW IR stages is these hit peak efficiency at around 17 amps of output current. There's 14 of them here. 14 times 17 is significantly more than 200 amps. It's like 230-ish. The end result is that this VRM, for optimum efficiency, should actually just run as a 6-phase for ambient cooling on a Ryzen 3rd gen CPU, even the 16-core. And if you have less than 16 cores, then actually most of this VRM shouldn't be running at all, because there's too many damn phases here. Actually, no, they don't have that many phases. It's just too many power stages. If you could turn half the VRM off, like half of the power stages in there, that would actually be kind of neat. But you can't do that because they're in groups of 2, so can't do that kind of thing. Anyway, the efficiency for this VRM is still it's still good. It's just that it's not perfect because too many power stages and not that many ways to control them. Though ASUS still does have the option to just turn off full phases. So if you have like an 8-core, this VRM might only run on 4 phases instead of all 7, because 4 phases would be closer to peak efficiency than running on 7. Anyway, so 1.2 volts output voltage, 400 kilohertz switching frequency, and 5 volts drive voltage. Which actually, this issue I mentioned with the low load efficiency, that's an issue that all of the super high-end boards have, because you just have to, like, the power stages are meant to... Like, the high current power stages all hit peak efficiencies at around, like, 17 to 20 amps on some of them. And so when you have 14 of them or something, it's just like, yeah, you're not going to hit peak efficiency on 14 phases worth of 20 amp power stages, or, well, more like 14 phases of power stages that hit peak efficiency at 20 amps, because Ryzen's just never going to pull 280 amps, right? That's kind of the issue. But anyway, it's really like it's single-digit wattage differences. So it's like for laptops, you would actually care about that. For desktops, who cares? Like your fans pull more power. Your LEDs pull more power, probably. If you have enough RGB, I'm sure you're burning more power in RGB than in VRM inefficiency due to unnecessary power stages running. So anyway, 100 amps output, this VRM will be producing about 12 watts of heat, because like this sounds really bad for 100 amps output compared to some other boards, because again, I'm calculating this with the full 7 phases running. Peak of, like, this would actually run better if it was running like 5 or 4 phases instead of 7, because this is like, if you look at the efficiency curve of a power stage, it looks like this, and that 100 amps output for this VRM is like here. It's really far away from the peak, and actually it looks more like that. Like it levels off there. That's better. But yeah, so 100 amps output, the efficiency isn't spectacular, but it's not going to be a problem for this VRM to dissipate that kind of heat, because that's less than 1 watt of heat per power stage. And, you know, due to how large this VRM is, it'll dissipate that just due to its own surface area. You don't even need a heatsink for that. So that's like a 3rd gen 8-core Ryzen right there. 150 amps output, you're going to be looking at about 17 watts of heat, which again, the VRM will dissipate just by nature of being huge. Don't need a heatsink for that either. And that's like a 12-core Ryzen 3rd gen. Maxed out, Prime 95, small FFTs, water-cooled. If you raise the voltage any higher, it'll start killing the CPU. That's the kind of current, like, that's what I set the current ratings at, right? Like, worst case possible scenario, overclocked. That's within what you could actually run daily. 200 amps output, you're going to be looking at about 20 watts of heat. And if this VRM actually dropped us a full phase, it would be producing maybe around 19. So, you know, like 1 watt difference. Because this is starting to get actually pretty close to the peak of the efficiency curve. And still, 20 watts of heat, and that's with the 16 core, again, running just completely maxed out. And then going past that, we get into the LN2 overclocking territory current draws. So 300 amps output, this VRM will produce about 28 watts of heat, which this might still be possible for the VRM to handle without a heatsink. So yeah, you could probably do, actually with LN2 overclocking, the board will probably freeze through at idle all the way to the VRM. So yeah, you probably can do LN2 overclocking on this with no VRM heatsink whatsoever. I'm not sure if how much current the 16 core pulls on liquid nitrogen yet. I do know that on ambient it won't go over 200 amps. But on liquid nitrogen, I don't yet know where it actually tops out. But if it tops out at 400 amps, well, then you might start needing a heatsink depending on how long the benchmark is, because you know, some of the benchmarks might be long enough to actually get the VRM to overheat if it lasts like, I don't know, 10 minutes or something like that. Because that is a lot of heat. Even for a VRM this large, that is a lot of heat. So yeah, at that point, you know, you might actually need a heatsink to sort of delay the heat out, well, the overheating. But for shorter benchmarks, you still wouldn't need a heatsink. And then 500 amps output, you're going to be looking at about 61 watts of heat. Definitely need a heatsink. And arguably, if you wanted to run that kind of current draw at ambient, you'd need a water block or, well, actually no, big heatsink with a lot of fins and some fans would actually handle this just fine. That's the thing with heatsinks, is just like, if it's fully passive, then you actually need a disproportionately massive heatsink, because passive heatsink, like, a fan makes such a huge difference to your thermal dissipation, which is kind of why all the chipsets have fans. And that is not an insignificant number of fins on that. Like, I should have pulled up a better photo of that, but there's, like, that's a real chipset heatsink, and they still have a fan on it, and it's just like, okay, well, I guess the chipset does get hot. Anyway, yeah, so the VRM here, though, like, nothing to complain about. It's not the strongest VRM on X570, but it's definitely plenty powerful. You know, like, it still doesn't compare to the monstrosity that Gigabyte has on the X570 Extreme, except, like, the X570 Extreme, like this board, for extreme overclocking especially, this board is much cheaper, and it offers a much better balance of features. Like, you have safe boot, you have retry, you have the LN2 mode, you have, you know, well, you don't actually have dual BIOS, funnily enough, but you have slow mode. You sort of have all the extreme overclocking features you need. You have a very powerful VRM, so, you know, that you're not going to be held back by that. You have the hole in the CPU socket. Like, you have everything on this board that you need. So it might not be the very best, but it's definitely not bad enough to actually matter, because this is ridiculous overkill. And honestly, even I'd be surprised if the Crosshair VII Hero would have issues with like a 3950X. Like, it should still be able to handle it. It might require the VRM heatsink, but it should still be able to handle it just fine. So yeah, this board is, like, you know, it's really, really solid. It's not the, you know, it's not necessarily the most powerful or the most complicated VRM design on the platform, but it's certainly not bad. So yeah, I'm totally a fan of this. Like, as I said earlier in the video, for the motherboards in this price range, you could take a die, label it ASUS MSI a Gigabyte, roll it, and whatever lands up is a good choice, because all the boards, at least on paper, look really, really good. So yeah, that's kind of that. Now, I guess moving on from that, so we've done features, we've done VRM, vCore. Oh yeah, memory VRM, ASUS is using the usual two-phase with the ASP1103. So, and ASUS is kind of, well, MSI I think also has a two-phase memory VRM, so they're not alone in that. But yeah, ASUS just does standard two-phase memory power. That's the thing they do. They do have this new OptiMem 3 marketing thing, but I'm not sure what, like, I don't know what that actually means. I did notice that, you know, on the back of the board, we can see that they're doing the same thing that MSI is doing with the full ground fill over all of the memory traces. I'm not sure that this board, like, I'm 99% certain that this board uses a daisy chain topology, because daisy chain is just better. Like, T topology sounds good on paper until you put 2 DIMMs in it and it sucks, and then you put 4 DIMMs in it and the memory controller can't deal with it and it also sucks. So yeah, that's kind of what's going on with that. Also, with daisy chain, it's actually kind of optimal for extreme overclocking, because you're generally going to be just on 2 DIMMs instead of 4. And then even if you're on 4 DIMMs going for like 32 gigs of RAM or something like that, daisy chain is not so bad that it wouldn't do 3200 megahertz. The issue with Ryzen historically and high quantities of memory in terms of memory clock speeds is not so much the board topology as much as it is the memory controller just not being very good. Like, daisy chain boards for Intel, for example, have had no problem going up to like 4000 megahertz with 32 gigs of RAM. That's not an issue. 64 gigs of RAM also, you know, not an, well, I think 64 gigs of RAM might be pushing the limit, but that's also because 64 gigs of RAM these days means quad rank. And then it's like, oh, well, the memory controller might not be able to deal with that anymore. So yeah, there's more, like, you know, the memory topology only matters up to the point where the memory controller of the CPU can actually deal with it, right? At some point, you're going to have so much RAM that the problem is not your motherboard, it's your memory controller. And historically, it's been Ryzen's memory controller. Now, Ryzen 3000 seems to have a much better memory controller, so who knows how this will work out, but I can't see daisy chain holding board like being a problem until in excess of 4000 megahertz. Assuming the memory controller is any good, in up to 4000 megahertz should not be a problem on a daisy chain, regardless of how many DIMMs you stick in it, assuming that both the memory controller and the DIMMs are capable of doing it, right? So that kind of thing. Anyway, so yeah, the Optimum 3, I actually don't know, like, the thing about the Optimum 3, so this board's almost certainly a daisy chain, especially, well, I think ASUS's T topology also requires that you use the outer DIMM slots, which is, I think it's only Gigabyte where their T topology is so heavily T topology that it doesn't matter where you put the DIMMs. It's just like wherever you find the most aesthetically pleasing. So even something like this actually works on Gigabyte boards just fine, or more like it doesn't work any better than if you did something like this or this or this. Like those all work equally well on Gigabyte T topology. But ASUS T topology, I think, still biases towards these two DIMMs, and then it just works better if you have 4. But this is probably a daisy chain, and it'll bias towards those two. Anyway, the Optimum 3 thing, I don't know if that's the thing is board vendors like to talk about all this extra stuff they're doing, and they come up with fancy marketing terms for it, and it's like, I have to wonder if like MSI might be doing the exact same thing and Gigabyte might be doing the exact same thing as ASUS, and it's just ASUS came up with a clever marketing name for it, so they have the Optimum 3 thing. So I'm not saying that they're not doing anything. I'm just saying they may not be doing anything different from anybody else that actually knows what they're doing, right? And they might actually be the best at memory overclocking, but this is one of those things you have to judge on like from actual reviews instead of like, hey, ASUS says they have Optimum 3. It doesn't mean anything. That's a marketing name. They came up with something. They could be doing the same thing as everybody else. Just have a fancy name for it. So vCore we covered. Oh yeah, I forgot to mention that SoC VRM this doesn't have an HDMI port, so you can't really overclock an APU on this anyway, so the SoC VRM is kind of irrelevant for that reason here. Yeah. So, and then here's the VRM heatsink. It's not the most finned thing ever, but as I said earlier when going through the VRM efficiency, you don't really need a heatsink on this motherboard anyway. Oops. Ah, damn it. You don't need a heatsink on this VRM anyway, so yeah. Really, like, it's a really solid board. I mean, it just kind of continues what the Crosshair VII Hero did, which was Crosshair VII Hero, best extreme overclocking motherboard for X470. This, probably the best extreme overclocking motherboard for X570. So, yeah, that's kind of my judgment. And I'm saying probably because ultimately you still have to test it, right? But on paper, this looks really, really solid. And a lot of the, this is better. Like, this has a lot of the extreme overclocker quality of life features, like the things that just make overclocking much more convenient to do, that a lot of the other boards actually lack. So, yeah, that's kind of that. And was there anything else I wanted to mention? Oh yeah, this VRM is actually the same VRM you get on the Crosshair 7 formula, and I mean Crosshair 8 formula. The water block on the Crosshair 8 formula, as a result, in my opinion, is a completely stupid gimmick and a waste of money. Just going to throw that out there. Okay, like that water block is the most... Actually, it's most high-end motherboards are like that, where it's just like, oh, look, our high-end motherboard comes with a water block. It's literally the most useless thing we've ever put on our board, because it doesn't do anything, because the VRM arguably didn't need a heatsink in the first place. It's like, if the VRM's below like 80 degrees, it'll last forever. And it's just like, well, the water block will make it run at room temperature. Great. Like, whoa, such benefit, much lifespan increase. Instead of lasting 10 years, the motherboard will last 100. Well, actually, the funny thing is, the VRM on a lot of these high-end boards is probably going to fail like long after everything else on the motherboard broke down. So, at that point, it's just like, yeah, the water block is extending the lifespan of the most robust part of the motherboard even further. You know, like of all the parts that didn't need any extra upgrades, it's just like, yeah, water block on the VRM that barely needs a heatsink. But, you know, marketing decisions. How do you make a high-end motherboard more high-end? Whack water cooling on it, even when it doesn't need it. They should have water cooled the bloody chipset. That would have actually made sense in my opinion, right? The chip, like, a lot of people don't like fans. Water cool the chipset. Though the thing about water cooling the chipset is that if you put a water block on the chipset, people who buy the board and don't use water cooling would be completely screwed. Like they'd be so screwed because the chipset, like if you have a water block with no water, it doesn't work at all. So yeah, that's probably why they decided to water cool the VRM instead of the chipset. That would arguably benefit from that more. Yeah, no, I guess they could have put like a heat pipe to the VRM water block from the chipset so that if you water cool the VRM, it cools the chipset down as well. And then the fan wouldn't have to kick in. But that's far too reasonable. Making the water block actually useful, you know, that can't have that. Yeah, I've run out of things to say, I think. VRM, good. Features, great. Memory, daisy chain. Who knows how it'll actually work out. And, who like we'll see, I guess, in reviews how well the different memory topology, like how well the different memory layouts from the different board vendors work out. But right, like I'm not going to judge motherboards from pictures for memory overclocking. It just doesn't work. I can't see the traces, and even if I could see the traces, I wouldn't be able to judge them. So yeah, that's kind of that. Anyway, so yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. Huge thanks to the guy who sent these photos in, because as I said at the start of the video, I'm not supposed to even have ASUS motherboard pictures at all. But I do. So, well, I have this one. So these for this board. So that's great. And I will be doing more ASUS boards after launch. I'm just going to pick up, like, I'm going to be buying a couple of them. So you can't stop me, ASUS. I'm going to show people the truth. You don't have phases. Well, I mean, 7 is enough. But where was I? Like, share, subscribe. We've gone through that. Right, if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. That gives you access to the AHOC Discord, and yeah, that's actually kind of it. And there's like bonus videos there and other stuff. And there's also, if you want to buy merch or something, there's the AHOC Teespring store where you can pick up like shirts, socks, posters, stickers, and that kind of thing. So there's a link to that. Both help out immensely with running the channel, because, you know, how else am I going to pay for motherboards that I can't get review samples of, because apparently I've offended ASUS with something. It's probably everything I've said about their Z390 lineup. I can't help myself. Like, their Z390 lineup just doesn't make any sense. Like, honestly, they have boards that cost less money with better build quality than the boards that are more expensive. At that point, it's just like, guys, what the hell are you doing? But yeah, that's it for the video. Thanks for watching, and I'll hit the stop button at last, otherwise this is never going to end, is it?